right, 7-3. You're going to need your yellow formula sheet for sure. That is the formula sheet you're going to get on the test. I will print a new one just in case you've added stuff to it. 7-3 is kind of tying it all together. I personally love 7-3 because it's a giant puzzle. I love puzzles. It is one of the hardest sections to teach, so that's where I don't like 7-3, because you either see it or you don't see it. And remember, it's a hoop. You got to get through it, okay? I will say that the homework is going to be the hardest part, which is why we will do that tomorrow as a group. You should start it, but if you're struggling, just stop, and we'll look at it tomorrow. 7-3 is proving equations, okay? You're manipulating. It would be like if I gave you a giant multi-step algebraic equation and I said the answer is 2, and I said prove it, you would solve it, right? And you would try to come down to 2. You already know the answer, you just have to manipulate it down to get 2. Same exact concept, except the difference is instead of it being an algebraic expression where you got parentheses, exponents, multiplication, division, addition, subtraction, instead it's a trig expression where you have your yellow formula sheet of all that mess that could come into play. Not all of it at once, but like if you saw a cosine squared plus a sine squared, ooh, that's actually 1. You know, if you saw 2 sine x cosine x, that's actually sine of the double angle formula. So it's the same concept as solving an algebraic expression, knowing the answer. You just have to get there. It's just we're doing it with trig functions. You already know the answer. That's why I find this easier than if you go back to 7-1. I'm just going to use, yours is in the back of my head right now because I just helped you with it. I think it was like 12 minus secant squared x over secant squared x. Okay, if I just threw that at you and I said simplify that down to as small as you can get it, to me that's harder because you don't know when to stop. You know what I mean? So this was 7-1. This is what we covered in 7-1. In 7-3 would be like me saying to you, cosine 6, cosine 2. Okay, we just did this one. So if 7-3 is me saying to you, hey, here's a trig identity, prove it. Now you know, okay, so this is a lot of stuff. I've got to manipulate this to equal that. So I find 7-3 easier because I know when I'm done. You know what I mean? I know where to stop, and it's also like a, yep, got it, I'm done, I can move on. Whereas 7-1 is more open-ended, where you just have that, and the most common question is, I don't know when to stop. You know what I mean? Which is exactly why on this test, I'm going to give it to you on the next day for corrections, because if you were manipulating this, we came to 12 minus, no, we came to 12 cosine squared minus 6, and I figured the computer would be happy with that, but we looked at view an example, and they wanted you to go further. They wanted you to factor the 6 out. So for this test, I would just highlight, let's say this was number 4. I would like highlight number 4 and hand it back to you, and I would make a note, keep going. You know what I mean? So that's exactly why we are doing corrections on this test. All right, let's dive right in. So there's nothing new here. It's just using your yellow formula sheet. It's working it like a puzzle. It's manipulating either one side or both sides. All right. The first one we're going to do is where you work just one side until it matches the other side. Now, how do you know which side to work? Well, you look at the equation and you ask yourself, you know, what's not worked out or simplified out? In my opinion, when I look at that, I'm saying I think that's done. Like, there's nothing to square, there's nothing to combine, there's no work to be done. Whereas if I look at this side, I can see right here, oh, they want me to square that binomial. That's your clue, like, okay, that's the side you're going to manipulate. All right? So let's make some notes. We are going to take this side, and we're going to manipulate it. If you don't like that word, you could write, we're going to simplify it. And the goal is, now, get used to these acronyms, LHS and RHS, not Ringgold High School, I mean right-hand side. The goal is to manipulate the right-hand side until I get the left-hand side. So I'm going to take the right-hand side, this is me, and this is what I expect to see on your test. I expect to see you labeling like what side you chose to manipulate. Because then as I'm like checking it, because I'm going to check every single person's, it's a lot easier for me to follow. Okay, so I'm just going to copy that.
Mark off if we change the variable because I'll
Variable?
yeah,
Like the of part?
Theta, like
No.
I'll put like X.
No. I'm not going to mark that off. That's another reason why we're not doing it on my math lab, because they would mark
I've gotten a lot wrong.
Yeah. They would mark that off. All right. 2 ways to go about this. First of all, don't you dare say that multiplied out is sine squared plus cosine squared, which equals 1, and I'm done. Don't say that. That's a binomial times itself. So that's a binomial times a binomial, which multiplies out to be a trinomial, okay? So please don't do that common mistake of, oh, I just square both of them, and I'm done. You can work with this if you want to, or as I have done before, you can come in and say, okay, sine is what letter? Y, and what's cosine? X. So you could rewrite this as y plus x squared and work with that. And then at the end, go back and plug in the sine theta, cosine theta. So then you don't get caught up in all of the trig mess and the theta. Okay, so this means that times itself, right? That's what that means. Now this is that algebra 2 thing where you've got first, outer, inner, last, which I'm not a fan of because it doesn't work if it's a trinomial times a binomial. But when it's a binomial and a binomial, it does work. So if you want to go that way, you can. Or you've got the split repeat method. But anyways, we're going to multiply y to everything in here, right? Which is where the whole first outer comes from. So we got y squared plus yx. Then we're going to multiply this x to everything in here. Now I'm going to go ahead and write x times y as yx so I can see that it matches right here. Right? And then we have x squared. No clue. And then what do we have right here? We have 2 of them, right? Okay, so this is y squared plus 2yx or xy. It doesn't matter if that bothers you. Now, there's no more like terms, so here's where you're ready to go back and plug in your trig values. I'm going to change colors. So this was actually, sine was, or y was sine, right? Now, it says squared. That means the squared needs to go right here. It's not squaring theta. You're squaring the trig value itself. plus 2 sine cosine plus cosine squared. Now remember, can you see? Yeah. Please move closer, because I've been there and it'll give you a headache in like 30 more minutes. Did you forget your contacts or something?
Yeah, they ripped all the way to school today.
Ooh, that's not good. If you sit here, can you see?
Honestly, I don't think I can.
Okay. We're all friends here. It's no big deal. I'm gonna put you right here. You're good. I'm not trying to embarrass you. I've been there. I'm telling you, I've been there. And this test is next week, so don't risk. You're good. I'm the same way. If I don't have my contacts or glasses in, I can't see you. Yeah. Can you see?
But I got number one right.
Yeah. Please. And you're gonna have a headache because I saw you do this. I was doing that in 8th grade.
But
And
this,
I told my mom, and she was like, "We get here, and he says you have perfect vision. I'm a weak." And I'm like, I swear I can't see. Sorry. I love my mom. That day, she thought I was making up something. All right, so look at this right here. All right, so I substituted,
I got it up.
multiplied it all out. All right. Now, remember, you're not out there like just floating in the ocean with nowhere to go. You have a destination. Remember, this is the goal, right? That's the goal. You see it? There's 2 things that I can substitute in here, and I will be done. There you go. Okay, so this is where, and it's up to y'all. Like, on your paper, if you went from here straight to the answer, I would understand it. You know what I mean? But if you feel like you need to shift that cosine squared over here to this, you can if you want to. But, let me underline it. Sine squared, make sure that is a plus cosine squared is what? It's 1. Now they're gone, right? They're gone now. Okay, let me change colors. What is this? Go to your yellow formula sheet. You will see it is the double angle for sine. It is positive right here, so it would be positive sine of 2 theta. And that is the right-hand side, or the left-hand side, sorry. That is the left-hand side, which means I'm done. So it's clean it up, multiply it out, or add, combine like terms, then start looking for things that can substitute. Okay, so that's when you work one side to equal the other side. Now let's do one where you're actually going to be working both sides, because both expressions on the left and the right are messy. Okay? So we're going to now work both sides of the equation. And this is where basically you have 2 totally different problems, and you work it until you get to something nice and simple, and then you go to the other one and work it, and you should have the same nice and simple expression. Okay? So y'all know me, I'm going to take the left-hand side. Work with it first. We got sine squared x times tan squared x. So we're going to start working with this. Well, sine is just sine itself. What's tan though? tan is sine squared over cosine squared, right? So I'm going to write the first one's here. Tan squared is actually, I'm going to highlight in green to show where this comes from. Tan squared is sine squared over cosine squared. There's not a lot you can do right here. You've got sine squared, which is understood to be over 1 times. You've got sine squared over cosine squared. We could write that as sine to the 4th over cosine squared, or we could leave it like that and then start manipulating the other side and see if we happen to come to this. Because if I look at the other side, I don't see any 4th power exponents up here, right? Do you see that? So I don't know that I want to make this sine to the 4th power because I don't have any 4th power on the other side. So let's go manipulate the other side and see what we come to. So now I'm going to leave that as is and come back to it. It's a puzzle, remember? This is like picking up a piece for a puzzle, trying it in a spot, it didn't work, trying another, and then you're like, all right, I'm just going to hold on to that. Because I know it goes right here, I just don't know exactly where. So I'm going to take the right-hand side. Now this is slightly different. We don't have these multiplied together. Now we have them being subtracted, and tan is a fraction, right? So this implies, let's get this in fraction form and get it to a single. Because look up here. Do you see any subtraction signs in there? None. So this is where you use the left and the right side to kind of guide your approach. I have a subtraction sign over here. I'm going to write this out. Tan is sine squared over cosine squared. And I have a big old subtraction sign. Sine is understood to be over 1, right? I want to be able to write that as a single fraction. Remember the rules of combining a fraction and an unlike denominator fraction. So your LCD, your common denominator, is going to be cosine squared. So this one's missing that. So I'm going to multiply this by cosine squared. Listen, look how I abbreviate it so I don't get caught up in the trig mess. I'm going to multiply that by cosine squared over cosine squared, because that's just a fancy 1. That's why I can do this. I'm really not changing anything. And now I'm going to rewrite this, because now, once I multiply that, now these will have matching denominators, correct? Which means now I can write this as a single fraction, correct? And then now just read it across the top very carefully. Across the top, we got sine squared minus sine squared cosine squared. Okay, so looking at this, you should think to yourself, all right, coming back up where I was, I've got a single fraction now, but I've still got this subtraction right here. I don't have a subtraction where I was on the left-hand side. So that's your indication that somewhere something's got to substitute, right? That's the only way to get rid of that subtraction. You've got to have some type of expression that is going to be substituted that no longer has the subtraction in it. So look at the top. What do you notice they both have? They both have a sine squared. So I'm going to pull a sine squared. Now imagine, let me change to black. And I'm going to come over here and say EX, like for example. What if I had y squared minus y squared x squared? They both have a y squared. If I factor a y squared to the front, I would be left with what? So if I factor a y squared out of a y squared, I'm left with 1 minus x squared, right? Do you see that? So if you're doing this, and you think you're going to mess up because of the trig mess, go back to just plain x and y's. It's sine and cosine, and it's a lot easier to see because y'all should all know how to do that. That's algebra 2, algebra 1. You should know how to do that. Okay, so right here, I'm going to factor sine squared to the front. I would be left with 1 minus cosine squared. And this, again, is all over cosine squared. Just like before, I wrote too big. I don't have much left, but I definitely don't want to crowd it. Now, this is where you look at your left-hand side as a guide of when you know you're done. Look at the left-hand side up here. Look at the right-hand side. You see something that already matches. What part? Yeah, I'm going to use my highlighter here. Let me pull yellow up. See this right here? Now this is ugly, I get it, but look right there. You got in the front sine squared, that's multiplication, over cosine squared, so that already matches. What's 1 minus cosine squared? Sine squared. So when you, again, it's a puzzle. So you look at it and you say to yourself, does something already match? The yellow highlighted already matches. Then you ask yourself, okay, what's left? How can I get what's left to match as well? Over here, what's left is sine squared. Over here, what's left is 1 minus cosine squared. Remember the very first day? I'm going to put right here. Okay, I'm going to put right here, recall, ... and I'm abbreviating it. Remember the first day we learned sine squared plus cosine squared is 1, right? And then I said, and if you take and do the cup game with each of those, you get 2 new ones. Let's see, 1. So if I subtract cosine squared over, I get this. Well, there's your substitution. That 1 minus cosine squared is actually just sine squared. So right here, you would rewrite this, and there's multiple ways you could do this. You could leave that as is, or you could pull this. You could substitute. Let me change colors. You could take this and write that that's sine squared. And then you could write what's left, which is the sine squared over cosine squared. This is still understood to be right here. It doesn't matter. Up here, you can just extend that. It's the same thing because it's multiplication. There's no addition or subtraction. So you're done. Now it matches. This is the left-hand side. So it matches. I personally like manipulating one side to equal the other. I don't like having to do both because I kind of feel like your mind is now there's multiple browser tabs open. One's playing music, you don't know which one it is. But that's a technique. You can manipulate both sides to match something in the middle. Okay? Let's do the next one. Let's go back to just good old-fashioned manipulating one side to match the other. Should be clear which side I'm going to work on. What side am I going to manipulate? The left. Because the right's just secant, right? Now, it might help to tell yourself right here, what is secant? Secant is 1 over cosine. So it might help to write that there so that if you end up at 1 over cosine, you don't forget, hey, that's actually secant, you're done. You know what I mean? So we're going to manipulate the left-hand side. So I'm going to rewrite it. I've got sine of a double angle over sine of a regular angle minus cosine double over cosine regular. Now, do not run in there and start canceling the x's. Can't do that. That's the of part. The of can't be touched. This is sine of 2x, and this is sine of just x. You can't go in there and cancel those x's. So don't do that. Clearly, the right-hand side is of just plain x, right? So your indication is over here where you got your double angle formulas. What should you do? Let's substitute them with what they're equal to in the single angle formula. So go to your formula sheet. Sine of 2x. Sine of 2x, I'm going to color coordinate this, is what? 2 sine x cosine x. Okay, I'm going to rewrite the bottom. Oh, look at that. That's going to be nice. Kind of already see where that's going. Minus, now, remember me saying when we learned about cosine 2x, there's 3 choices. And here is where, once again, why we're not doing this on MyMathLab. And then you're going to have to, on your test, let me know, which one you picked. I personally, I went with the first one. I don't know. I guess it was just that overwhelming freedom of choice. I just decided to go with the first one. So I went with cosine squared minus sine squared. You don't have to. There's also 1 minus sine squared, or there's 2 cosine squared minus 1. Doesn't matter which one you pick. You will, depending on what you pick, you will have different manipulation along the way from here on out, but you should still get to the final answer. Alright, this is over cosine x. Let me use my highlighter. So that double angle became that one. Now, if I had to guess where people are going to go wrong here, it's going to be right here. That is a minus in between, and you just put after it multiple terms, right? So that minus right here, if it helps, or if you need to, you can say, okay, I'm going to make that a plus, and then I'm going to put a negative right there in front of those parentheses. Because what's going to happen? It's going to distribute. And what happens is people miss that sine squared becomes positive, and then it messes everything up. So be careful here. If this was like a fraction minus a fraction, and you just substituted after the minus sign, something with multiple parts, it's in parentheses, you're gonna have to distribute that subtraction sign. So if it helps, change it to that you're adding. Change it to that you're adding, that was still ugly. And then just put that negative right there in the front of the parentheses. So I have two things I need to clean up before I actually start going back to manipulating. What happens over here in this first fraction? Yeah, this right here cancels. Do you see that? You can do that because it's just all surrounded by multiplication. Okay, so I'm going to rewrite what I've got because there's a lot going on here. I've got 2 cosine x, and now it's understood to be over what? 1, right? Then I have plus, and I'm going to go ahead and distribute this negative. I've got negative cosine squared plus sine squared all over plain cosine. See what I did there? So distributed. Now remember the goal is 1 over cosine. That's the goal. Well, guess what? Look, what you already got. You already got cosine in the bottom over here. What does this one need? This needs a cosine. So we're going to have to multiply this. Change colors. We're going to multiply this. I mean, put the dot there. I'll just do this. By cosine over cosine. Right? Whenever I'm trying to get a common denominator, I only write the first letter of the trig that I'm using to get the common denominator so that I remember that I'm just multiplying that fraction there to change the way it looks. Alright, so if you have cosine times 2 cosine, you would have 2 cosine squared, right? Now, nothing happened over here, so I'm just going to write. Now, I no longer need the plus minus because the goal here was that we're getting this over a single denominator, correct? That was the goal. And we just did that. That's what the blue cosine here took care of. So plus minus is actually just minus, right? And then I'm going to put plus sine squared. Now take 20 seconds without me talking. Look at it. There's 2 steps left. Can you find it? There's 2 things left. Remember the goal is 1 over cosine. Well, right now we've got over cosine. So look at the top. There's something there. There's 2 things there. There's 1 thing you have to do, then there's a substitution. All right, let me help you if you don't see it. It's only the 3rd problem, so if you don't see it, it's okay. Don't be harsh on yourself. Notice right here, this is cosine squared x, right? How many? What's right here? Same thing. There's only 1 of them. Like trig function. Has to match the trig function, has to match the exponent, has to match the of. So just then think of it as those, remember me saying before, those kids' blocks where it's painted on the front? You got 2, you're taking 1 away, so that would leave me with just the 1 of them, right? So just a cosine squared x. Now because it just, there went the subtraction, right? Now it's gone because you just took 1 away. Plus sine squared x all over cosine x. What's cosine squared plus sine squared? 1. that mess is 1 over cosine x, which is just secant, and that is the right-hand side. The last example we will do at the beginning of class tomorrow, because it does have a key change flip involved, and some people panic with that. So we'll do that one at the beginning of class, and then we will go over the homework. Please start the homework, okay? Just start it. Don't come in here tomorrow with having not even looked at it and just a blank slate.